Hello and welcome everybody to Dissecting Data Quality. I'm Tyler Haire, I'm a data engineer with Management Performance Hub, and I'm going to be giving a little presentation here on data quality. And it's for anyone who missed our data day and wants to see this presentation again or needs to see it for the first time just to learn more about data quality and what MPH is doing about it. So give you a little bit more background about me. Born and raised in Indiana, got my undergrad at Purdue. It was a dual major, computer science and data science. And actually, if you were to draw a circle and take the diameter of where I grew up, where I went to school, and now where I work, it's about a 75-mile diameter or so. So I'm very homegrown. And I'm the newest data engineer on the DM team. And I bring a lot more of a data science background to the team, which we do have a whole data science team at MPH. So I'm helping essentially bridge that gap so we can have better lines of communication and collaboration and just work together even more effectively than we already do. And this will allow us to bring better products and deliverables to agencies, research institutions, customers that rely on us, and just have us overall be more effective for everyone. And that's enough about me. We can dive a little bit into the background about what we're talking about today so that we're all on the same page. So data ingest is at an all-time high, and it's always growing. I'm sure you all heard about TikTok, Google, all them taking as much data as they possibly can about you. And to do that, you have to store it in these massive, massive tables. So they border on hundreds of millions of rows, some go even to the billions, and then as many columns as you can imagine as well. So essentially, these data sets become far beyond human comprehension. No one's going to go through and independently verify anything about these tables at all. And that's an extreme example too. You can get much, much smaller to tables that only have a few hundred or a few thousand rows. Even those are going to be too unwieldy to actually look at. If you think of a giant Excel sheet, if you've ever looked at one of those, you don't want to go through and read them line by line, especially when there's tons of columns. You have to look at very large rows. It just makes it completely impossible to actually verify what's going on. That's why I say data here is almost a gray box. So with a black box, you have inputs and you have outputs, and you don't really know what's happening to get from that input to that output. But with a gray box, you can verify what's going on, but it is very cumbersome. And that's why data as a gray box is you technically could go through and look at everything and verify it, but to do that manually is just a massive time and effort waster that it becomes much more important to use metrics to figure out what is actually happening and what's going on with this data. And these metrics are growing at honestly a faster rate than the data itself because we have to get back ahead of what we don't know about the data. So that leads us into an overview right here about what we're going to, this whole presentation is about. So we have data quality's attributes. So there's 6 main attributes we're going to go over. We're going to go over each one's importance to data quality, what it is, its mathematical definition, all that, and then MPH's role in improving data quality as a whole. So MPH serves state agencies, that should be clear, and it's not just that, but we serve all Hoosiers. So when I say it's MPH's role, it's really a statewide effort to improve data quality when either it comes to agencies or individuals. We'll go more into that as well. But after all that build up, we can finally get into the nuts and bolts here of what this presentation really is about. And by that, I mean I can ask the key question, what is data quality? So data quality is encompassed by 6 key dimensions. They're not generally in any order. And sometimes you may see different names, slightly different variations of this. Some might only have 5 dimensions. Some might split up consistency and freshness, for instance. So there is a little bit of variation in this, but for MPH's use case, we find this to be the best one. And like I said, you might find other versions. So duplicates can often be referred to as uniqueness, stuff like that. But otherwise, they usually encompass the same core ideas. And now that we've seen what makes these up, this completeness, accuracy, relevancy, validity, consistency, and freshness, and duplicates, let's look at each one of these individually. So we'll start right off here with completeness. Now for all of these, we're going to have a definition. We're going to say why it's important. We're going to have a mathematical definition. We're also going to have an example on another slide. I'm not going to go through the math definition. That's more for people who just want to see what the actual math behind these actually is. I'll just go through the definition, why it's important, and then that example. So let's start right off with completeness. Its definition is the extent to which a data set has all the relevant and necessary information for a given purpose. I think this one is the easiest to understand. It's really just, is all the information there that you want to be there? If it's not, that's obviously a problem, since if you're asking for that information, it's probably important to some extent. And the only way to get that full understanding of the subject you're analyzing is to have all the data about it. Now, I think all of these are easier understood with that example, so let's move right along to that. So here we can see this table. Now we'll see this for every single example. This table will not change, just what is highlighted will, to pinpoint that exact part of the data quality attribute that we're looking at. So here we can see this empty slot with Jeff's last name. Michael Jordan has a null date of birth. Now null or its equivalent or an empty space are all the same thing when looking at completeness. Basically just empty data or data that is not there when you expect it to be there. And that's really all there is to it. Like I said, completeness is probably the easiest one to understand. So we can move right along to another fairly easy one, accuracy. So here is accuracy. Its definition is the level to which data represents its real-world counterpart. So whenever anyone says data is correct, they're talking about accuracy. So some people even refer to accuracy as correctness. Like earlier when I said they might have different names for these dimensions, that would be one of them. Now having correct or accurate data is obviously important because otherwise you can get very misleading statistics. It can even prevent you from having meaningful calculations altogether. And on a more like personal side, if you've ever been filling out online forms and they have to ask you to verify all that information, that's what they're talking about here, that you want to make sure that's accurate, that's correct, especially if it's like a medical form or anything like that. If it's inaccurate, it can cause health issues. On a less serious note, if it's like an Amazon shipping address, if it goes to the wrong place, an inaccurate address, you don't get what you want when you order it, and that's obviously a problem on just the personal side. So imagine that on a massive data set, trying to make sure all that information is accurate and correct. Now, I would like to say that typos are usually the enemy of accuracy. So really just double check whenever you're typing things in to make sure things are accurate. And then on our side as MPH, making sure things are accurate are very important for any algorithms or analysis we like to run. So we can look at an example here as well. So here we have me. My date of birth is not in 1950, despite what it may look like. And that would be an example of just an inaccurate birth date. Inaccurate phone numbers, addresses are probably the most common thing, a typoed name. That sort of stuff is usually the biggest culprit of inaccurate data. Like I said, that's accuracy, another very simple one. We can move on to a less straightforward one in relevancy. All right, and here it is, relevancy. For its definition, we say the extent to which data is useful across different systems or for different targets. This is important because data is not static. Right? It moves across many different systems, might serve many different functions, might only serve one function. But knowing the importance of each of those bits of the data and like what it's doing along that pipeline is critical to the process. You don't want to be moving a bunch of data around, storing it when it's not being used. Essentially you just have a lot of wasted space, a lot of wasted resources, and just ends up being a lot of wasted money. So, like I said, every system, regardless of size, there's going to be this pipeline for data, and it only becomes relevant when it's used. So like almost going back to accuracy, accurate data, you always want accurate data, but if you have accurate data that isn't relevant, again, it's useless. So you want to make sure it's always being used. This is another good one for the example. Take a look at that. All right, and here we can see that example. So imagine for a minute this shoe size column is completely useless. Like we don't use it anywhere along our data pipeline. We get all this information, but we just never use it at all. Now imagine this is a multi-million or even billion row data set. That is a massive amount of storage that's taking up. If there is processing being done on this data set or any sort of algorithms being run, they're going to take much longer and waste time if they're including that shoe size metric. So that is a wasted time, wasted money, all that stuff, which again, you just obviously want to minimize. So making sure you know that all the data you're getting is useful and relevant is another key aspect of data quality. And that marks the halfway point too. So we're halfway through these dimensions. We'll keep on chugging onto our fourth dimension with validity. So here we have validity. It's the extent to which data conforms to the standards of a specific domain. Now, validity is very easily confused with accuracy. In fact, if you look at the math definition here, you may notice they're exactly the same, except with this little photoshopped valid record in place of accuracy. So essentially they are the same thing, except validity has to do with the format and accuracy has to do with the content. So this is about making sure everything is basically put in the system the exact same way. So I'm sure many of you know there's many different ways to write a date, there's many different ways to format a phone number, all that sort of stuff. So making sure it's all of the same type allows very easy processing to be done on that data. And this is one of the most manually intensive things to fix if you have invalid data across a column. So again, we'll look at an example here. So here we have phone numbers, and you can see this hurts my soul to see all these different formats for phone numbers. So you can see some have dashes, some have parentheses. In this case, we would assume the valid format for this is to have these dashes, but unless you know the actual domain and the setup of these tables, it's impossible to tell. But again, this will be something we'd have to go in and format manually, depending on how this data is stored, which can just take a very long time and can be very cumbersome. And then I'm sure many of you can imagine how this would work with the dates as well. Some people do months, then days. Some people do days, then months. So it can be impossible to tell which one is correct if you don't know the domain again. So yet again, it can be very difficult to tell. But that covers validity, so on to our penultimate dimension, consistency and freshness. So this is a little combined one. For our purposes, we find that to be the best way to handle consistency and freshness. So how new the data is, that's freshness, and how many places it appears across the data set specifically, or across data sets, I should say, is consistency. So it's important because having stale or inconsistent data can hinder your ability to draw those conclusions from it. Basically, if data is very old and you don't know if it's up to date, that can lead to issues, especially if you have inconsistent data where across multiple data sets it is varying. And this is one where, again, it's super easy to see it with an example. Here is that table again. We'll see this bottom one here. Actually turn off my camera so you can see these dates. But you can see, assume this last row is an entirely new data set that also has John Smith, the same one we have up here at the top. You can see their phone numbers differ, but everything else is the same. And then if you look at their refresh date, which is something MPH has on pretty much all of their data sets, this one is much, much newer, over 10 years newer than the old one. This is a case where you would assume that this phone number is John Smith's actual updated phone number, but something that can be difficult to actually verify. And that is an example of here you have the consistency. It is inconsistent phone numbers across different data sets. That's a key part of consistency. It has to be different data sets. And then freshness, we can see this smaller data set here is much, much newer, much more fresh. So in that case, you would assume, like I said, this is the newer one. But again, it can be very difficult to do that. So keeping data consistent across all data sets is very important. Like imagine if these tables both pointed to different endpoints, different consumers, they're both getting mismatched information. But if they ever come together to work together or do anything, they'll realize that, hey, they're not getting the same stuff. So that's one thing when it's important for us to make sure everything that stays up to date. Now we can move on to our final dimension, a nice simple one with duplicates. All right, so here we have duplicates, commonly referred to as uniqueness, and a slight departure from consistency. This actually is measuring duplicates across a single data set, whereas consistency was about across different data sets. So this is where we get actual repeated values in the data set itself. As we say, it's the repeated instances of data in either row-wise or column-wise fashion. Usually row-wise, but it can really be depending on your use case. And it's important because unintended duplicate values can just break processes, they can create misleading statistics, all that. I know for MPH, and I'm sure plenty of other companies, there's processes that require unique values in certain columns, and if they're not all unique, literally every single one, it can just completely break things. So that's why it's important to make sure everything is unique when required. And duplicates might sound really easy, but I'm going to show you an example of why it's a little more difficult than you might think. So then taking a look at this table again for the last time, show you why it is a little more difficult to identify duplicates than you might initially have thought. So again, we have John Smith. You might have seen the repeated one down here, where every bit of information is the same, except their dates of birth. So here we have 1/2/75 and 2/1/75. And this goes back to validity. We're making sure things are in a valid format. Because if John Smith, his name was entered by two separate people, but one of them used day then month, and one used month then day in their date format, this is where you had that mismatch. So making sure everything is of the correct format to make sure it's valid is a key consideration. Here you can see exactly why. So this is a case where you don't actually know if it's a duplicate, but you can assume it probably is, even though most systems are probably going to say, hey, these are two different people. They just both happen to have the same name. Similar here thing with Jim Jam and Jam Jim. Everything is the same besides their names that are flipped. Again, it's a question of, is this an actual duplicate or are these two different entities? And that is where it gets more difficult to know, okay, what do we think? And there's not always an easy way to get the right answer, so it can be pretty convoluted in how you actually get there. Most systems, like I said, are going to say these are unique, all four unique entities, but something we're working towards is making sure we're actually identifying truly unique values and truly unique people here at MPH. So trying to get processes that can identify these sorts of things, maybe flag them as potentially taking another closer look, that's important to us. And that's it. That covers all 6 dimensions of data quality. So I'll show you guys those again. Quick refresher. Here's those 6. Now that we're all familiar with all these 6, we can look at the final important remaining question. That is, what is MPH doing about data quality? So there's really 4 key things we're doing. We're creating scripts to run these calculations, all those math definitions. We have to create the back-end code to actually calculate all that on all the data sets that we have and all the ones that we will receive, which means we need to create a pipeline so that all future data sets can be run through it seamlessly so that we instantly know where they stand from the outset and then hopefully how they will look in the future and how they're improving. But to see that, we also have to have that information stored in a running fashion so that from the time we start making that record of its data quality to the time currently, we know any changes, ideally it's only ever going up in terms of its data quality score, but of course having that information in the running fashion will tell us that. Then the last point, the key one, at least for other agencies, is to make sure they have a way that they can see these results, that we can share them with them and that they're easily understandable so that they know exactly where they stand in terms of their data quality on every dimension. And that has all led to our internal project, the Data Quality Scorecard. And then here is that in all of its glory. So this is an agency level view of just a single dimension. We'll go through completeness, but you can assume it'd be very similar no matter which dimension we're looking at, just a bunch of relevant information about an agency. So this is what we're calling the Data Quality Scorecard. As I've said, it's still a work in progress, but something that we see other agencies and even potentially the public getting a lot of value out in the future. So we're going to go through each of these left to right, top to bottom, and I got the pointer out here again so we can see exactly what I'm talking about. So we'll start here with the largest recent changes in score. So any tables that have had big moves in whatever metric, like in this case completeness, that they're looking at, they'll see them right here. So whether it's a big increase, a big decrease, or things that have been very variable, tables that have moved a lot in both directions, they should all appear here. That way any agency or customer can know, okay, these are the most important movers, the ones that have really had a lot of change over the recent iterations. Then again, we want them to be able to see basically their breakdown, their distribution of all their tables as a whole, or as a whole agency, I should say. So whether they have a ton that are just average, a few that are low, a few that are good, just so they can give a breakdown and hopefully improve this as time goes on. And then many tables might, or many agencies, I should say, might have key tables, where they want to make sure they're viewing these tables specifically every time because they're the most important ones. They serve the most customers, they do the most this or that. They can always see those tables show up here, and they'll be able to mark whatever they need so they can see whether their table is consistently bad, consistently good, whatever it may be, just so that they can see that table in particular. Then down here we'll have some general statistics for all the data we've done. That's more so just to help them make sure that the data that we're getting is exactly what they think they're sending us. Sometimes there can be a little bit of confusion and lack of communication when it comes to transferring data across agencies. So this helps them realize that, hey, we are looking at all the data they're giving us and they can make sure that is what they're expecting to give us. Again, we have more auxiliary information. This will most likely end up being an overall score as opposed to total tables analyzed, but yet again, still a work in progress. An important one though, compared to last time, that way they can see marginal changes, iteration over iteration of when we run this analysis for them, whether they're giving us a lot more data, whether their overall score has changed a lot, other important information. Again, analysis on what has been done down here. Then a placeholder for relevant information. There's basically no one-size-fits-all solution. So we want to save a little space so that agencies, if they had their own important information that may or may not be part of the metrics we're getting, we can display it here for them and do a little more custom work. And then we also have a lower level to look at. So this is, like I said, an agency view, a high level, you see all the tables. So now let's look at the lower level and look at a table-wise view. So here is that. Imagine we have one of those key tables before. Now we can dive into it, this table level scorecard view. So a very similar setup to what we saw before, where we have a timeline of how it has changed since whenever we first ingested it, or whatever time span you so wish to view. You can see yet again how it's moved. You can look at, instead of table-wise, we now have column-wise, so that each individual column gets its own version of analysis. So like I said, in this case, completeness, they can see every single column they have. In this case, like X and Y literally have 0, where it leads to down here, the lowest ones for whatever metric it might be. So in this case, X and Y, see have the lowest completeness. So those might be ones to look at, column-wise at least. An overall table score, which helps make up their overall attribute score as an agency. And then again, compared to last time, that marginal change, the overall analysis done. Things like uniqueness here too. Some agencies may value having highly unique data, or some might value the opposite, making sure the data is not unique because it's only supposed to be true, false, this or that. Again, these are works in progress, so we're constantly refining them, getting feedback to make sure this is the best possible deliverable we can give to the agencies for their data quality. All right, and now a key consideration I want to make is that this is us versus data quality, and when I say us, I don't just mean MPH, I mean all Hoosiers, everyone who's making data. Basically, it's every one of us versus the problem. And I want to say this scorecard is not a demand from MPH for agencies to improve, to do anything this or that, just a way for us that we feel we can help everyone improve their data quality overall. Like it says here, data quality is the problem, not any particular agency or entity. And then this scorecard versus report card mindset. This is a scorecard to provide valuable feedback and maybe a guideline for other agencies. It is not a report card to take home to mom and dad or the higher up, so to speak, at an agency and tell them, hey, you've done bad, you need to fix this. No, it's a scorecard. Just say, here's a way to track your progress so you can internally try to improve and just get better data overall and help you make better decisions down the line. And then everyone can help improve this regardless of role. I think a lot of people think this is just an agency level thing or just a data collection thing, but we're also the ones producing the data a lot of the time. So it's always good to try to point out places or instances where data quality can be done better. So for example, those dates, if we go back to date, format, and validity, a good thing that can be done is having those little calendar boxes where you choose the year and then choose the day and the week from a calendar. Those make it so it's impossible to choose the wrong format. You always choose the right date. So suggesting that anytime you see a date field, if there's ever like a suggestion box, is a good thing to do, just as an example. So just a way for us as individuals to help improve data quality, since we're all generating the data, even if we're not all the ones collecting it. Along those lines as well, free text fields are a nightmare to parse through. So anytime you just type out stuff, that can be usually extrapolated into either checkboxes or something along those lines, a drop-down menu. I know it's not always applicable, but something where if you see a text box and it's obviously stuff that just could be put in a little more discrete fashion, that's another thing we can do as individuals to suggest things like that. All right, as a quick review, we have those 6 data quality dimensions, and then we talked about what each dimension contributed to data quality as a whole, along with MPH's role in improving data quality via that scorecard, so that agencies can come to us and get a good toned down metric of what their data quality is for each of those dimensions. We also went into a little bit about how everyone can help improve data quality regardless of their role. So as individuals or as people working at agencies and collecting the data itself, no matter what you're doing, there's always something to be done to better data quality. All right, so if you'd like to dive a little deeper, you can view the other presentations that have also been recorded. So these times obviously are not useful now since data day is over, but Brent and Santosh did record their presentations as well. So if you want to see a little bit more into the back end of how these tools were developed, more specifically how the math was actually coded, you can go and see Brent's overview of DS tools that he made. He's on the DS team. And then a fellow DM team member, Santosh, he had a whole presentation about AI and of course ChatGPT. So go see those if you're interested as well. Overall, thank you for your time and watching this presentation. Hopefully it was a nice overview of everything data quality-wise that we're doing here at MPH. And I'll finally leave you here with a little contact card. You can contact me directly or MPH as well, and sign up for our newsletter if you're so interested. So thank you very much again for watching, and have a great day.